Welcome, everybody, to this week's episode of House Calls Vermont. This happens to be our fourth episode installment. So all you listeners and viewers, glad to have you here, especially those who are interested in building projects, building science, and how to avoid issues and solve problems at the same time. This week, there's a very important topic that's near and dear to our hearts, because it should be near and dear to everybody's hearts and minds and bodies, just because it deals with a lot of health and safety issues, along with making the investments that we're putting into our buildings, whether it be an efficient, energy efficient improvement, or an addition, or just a brand new house. But it's going to make it last. It's going to make it more durable. And at the same time, when we deal with these items, it's going to make the building more efficient on its own. It's indoor air quality, and indoor air quality, or IAQ, has become more and more important in the last several years. I say decades, really, because our buildings by default have been getting tighter. The leaky old farmhouse, where you might be the old New Englander and said, I've burned 14 cords of wood a year and I'm fine with that, and my house is as leaky as can be, but we stay warm in there. Well, usually, truthfully, you stay warm in front of the fireplace or the heating element, and that's about it. And then once that air leaves the building, other air is going to come back in to equalize the pressure. It's just simple physics. When it does that, it's bringing the air back in through places you really don't want it to, through mold areas, through what the rats or mice have left behind, or something like that. You're going to be breathing that in. And also, if you have other toxins in your wall systems, whether it be asbestos-related insulation like vermiculite, or if you, like I said, if you did have mold somewhere else, or lead dust, that can bring that into the airstream, and those particulates can be especially dangerous to the occupants. And so with this, tonight, what we're going to do is we're going to explore some of the things that we should look for when we are looking at indoor air quality, but how do we make sure that we achieve that? How do we make sure we preserve that? And overall, what are some of the things that can help solve this issue? And so tonight I have Chris West, my colleague, joining me once again, and we join one another in this process. But he's here online with us. Chris, how are you doing tonight?
Hey, Jim, I'm doing well. How are you? I'm sitting here doing all the controls, and tonight is indoor air quality. Absolutely. We're going to be talking about indoor air quality, what causes poor indoor air quality. We also tonight have an interview. We have Steve Spatz back after a month or so hiatus. We got the opportunity to get him back, so I'm really excited about having him back, and we're looking forward to that. So we'll be having an update also from 10 Old Stage Road, the retrofit that I'm working on over in Essex, and we'll also be working on looking at an interview with Steve Dionne from Timber HP, which is a Gutex-like product that's going to be made up here in Vermont, in Maine. And so that is a local product that is a very good product, and we'll talk all about the basics that product has for us. But first, we're going to do a deep dive into indoor air quality. Absolutely right, Jim. So why don't you help us out with that? I'm having some trouble with my transitions for some reason.
Sure. Basically, how do we define it? You could look at indoor air quality as the air we breathe while we're inside. And this is particularly important in a colder state like Vermont, or in the New England area, anywhere in the northern tier across the United States, because we're usually going to be inside these buildings for a prolonged amount of time during the year with everything closed up, because as we're trying to warm the environment inside of our houses, we're going to close everything up. And so we could be rebreathing the same air over and over again. And if it's not healthy air, let's say you have a 100% healthy house, there are no contaminants inside whatsoever, and you don't cook inside, you could still have you probably will have elevated levels of CO2, which can cause, some other issues, cognitive issues, and anything above 1,000 parts per million can be one of those things that will contribute to you feeling tired. It can cause a lot of other issues, just cognitive ability issues, especially if you're sleeping in a bedroom with the door shut, and let's say it's a 12 by 16 bedroom, and you're sleeping with with your partner inside the same room, or even by yourself, and that door is closed. You're going to watch it elevate. In fact, my windows inside my home office last week when we were shooting the video, they were all closed, and my door was closed to keep it quieter. and my elevated CO2 levels was getting close to 2,000 parts per million.
How did
So,
you know that that was happening, though? Why don't you
no,
remind
nodding,
everyone?
I was nodding off. My eyes were closing. I started, singing weird songs. No, I
You,
actually, because we were using one of the IQ Airs, and they are not a sponsor. It's just one that we had found that came recommended, and it's a wonderful device. It's a kind of a bright light here. Sorry about that, everybody, but it gives us nice display, and it will show you. Green means a healthy, happy person, and to the other side, I think my camera's reversed, so you might see 703 reverse, but it's
no,
700.
you're absolutely right. It looks perfect.
Oh, great!
Yeah,
So it
and it
basically,
just went to the other display. But yeah,
sure,
we could see right now. I'm just seeing the time, but it's a great device. I mean,
yeah,
we've been using these in our homes, and we were supposed to be using this device for an indoor air quality survey that we're hoping to get done during the winter months. But we're having some trouble making this device work remotely. So we have to work out some bugs before we get that program really up and running, and we apologize for that. But if you are, we do have a list of people who are interested in doing an indoor air quality survey just to find out what's going on when they close the door in their bedrooms at night, or other rooms, because you can put it in any room. But in general, we're interested in knowing the types of contaminants that we're dealing with. So, Jim, what are the various contaminants that this IQ Air device checks out for us? What can it tell us?
well, it's certainly going to check indoor humidity levels, which becomes important because anything above 55% tends to start being problematic when you consider mold growth. Anything below 30% relative humidity will be a little bit too dry, and you might have problems with eczema or just dry skin, something like that. So it's going to monitor that. It's going to monitor in the indoor air temperature. It's going to be monitoring the particulates in the air. So if you have a certain elevated amount, especially when you're cooking, doing open cooking, it'll show you that. Or if you have a wood stove, and that wood stove will show you quite a bit there. If you have a time like now, it's the springtime of the year, especially in New England, where there's a lot of pollen this year, and if you have higher, amounts of particulates in the air, it's going to show you that. But the important one as well is the CO2 levels. This is not carbon monoxide, which is deadly and poisonous. This is carbon dioxide, which still, if you have too much of a concentration of that, it's going to cause some of those issues I was speaking about earlier. So it's a neat all-in-one device with a nice interface. It can hook into your cell phone, and you can watch it there. You can also hook into the town air quality where you live, and it'll show you if there's an elevated risk of certain things. Like if you are out west and you have forest fires or brush fires, it's going to show you those elevated particulates, and basically gives you a good snapshot of what's going on and what you might want to do to move to higher ground. No, but seriously, if you have you have an indoor air like an
Move
exchanger,
to
like
higher ground. Right.
yeah,
Sorry,
and you start,
that's a World War I joke, right?
yes, yes. But if you have an ERV or an HRV, something like that, heat recovery, energy recovery ventilator, you might want to turn that on, or a simple exhaust fan. But once again, you turn an exhaust fan on like a bath fan, the air's getting pushed out, but it's bringing other air back in through parts unknown through your house. So you may be, out of the frying pan and into the fire in that type of situation.
Right,
So
and very important just to say again, the reason that that something would re-infiltrate, right, is
yes,
that we're turning on a fan that's depressurizing the house. We're blowing air out of the house.
yes,
And if your windows are all closed and your doors are all closed, it's the heating season, and you're sitting there and you're depressurizing the house, or if the house has got a wind blowing on it, right? The wind will hit the front of the house, which pressurizes the front of the house, but the back of the house gets depressurized, right?
yes.
So there's all kinds of effects. We've spoken about the stack effect a lot as well. So there are really, from what Jim and I are talking about, three ways to depressurize. Well, four really. Way number one is wind. Wind will blow against your house. It will force the air on the wind side into the house, and will force air out through the back of the house. So that's one. Then we have a stack effect, and that's that hot air rises and that pushes up on the top, what we call the top pressure plane, which is usually the ceiling of the top floor, rooms, and that usually has holes in it that are very hard to detect just with the eye, and air goes up through that and depressurizes the rest of the house. That reinfiltrates. So that's way number two. Way number three is a bath fan or a range hood that flows air out of the house. A dryer is another example of that, and that pushing of air out of the house then creates a low pressure in the house that has to re-infiltrate, or as we call it has to repressurize, and it does that just through the path of least resistance. It's a classic term for this type of thing. And the fourth one, and it could be lumped in with the third one, is your combustion appliance. Appliances like your boiler or your furnace, if those are not using something called sealed combustion. If you don't, they're not ones that have a tube going from the outside to bring air into the directly next to or directly into the firebox, then you're going to be sucking air through, as Jim says, parts unknown. Your walls, the connection between the concrete part of your floor and the wood part, that band joist is a classic place where reinfiltration happens. And so those are the three ways that we can depressurize the house that have to repressurize. And there are a couple of ways to do that, but the major way to do that is uncontrolled infiltration through the envelope. That's my diatribe on that. Your sound.
Go.
Yeah.
And one of the dangerous areas is going to be, let's say you live with a very dank or just nasty basement, dirt floor, old rubble foundation, lots of rodents, bugs, whatever, and they're doing their business in your basement, and then everything leaks out. But a path of easy airflow or reinfiltration is going to be right through those walls.
Ew.
It's going to be an uptake of that, especially if you have rot and everything else, and then you're going to be breathing that. Is it going to be an instant health concern? Not necessarily, but the body can take only so much. And once it's bombarded through our environmental hazards that exist out there everywhere we go, I'm not trying to cause anybody to get overly concerned, but we face this every day, and your body can catch up. When it can't catch up anymore, though, and the scales tip out of balance, and you're living in this space, especially now when people are working from home more often, you're living in this space, let's say 8, 12, 16 hours or more a day, and that environment doesn't change for the better. That's going to have an overall effect of your once again your tiredness, your cognitive ability, your general health and welfare type of thing. And so you want to make sure that this is in good standing. It's operating effectively. And some people say, well, I'm going to change out my filter on my furnace. That only goes so far, because that's one of the bigger things too that we find when people get a nice HRV or ERV to handle the indoor air quality, or a simple bath fan, or a furnace that has one of these attached as well, one of the HRVs or ERVs attached. They're not changing the filter. And what that's doing is, one, causing the equipment to work much harder, but also it's not really helping you. I tested out an air handler or an air exchanger the other day, and it was probably 2018 install, so about 3 years old. And the gentleman says, yeah, I change these out regularly. I opened it up and said, Matt, when did you change these last? He said, well, I got to be honest, the day it was installed. And you could tell. I mean,
Well, that's still regular.
well, yeah, exactly.
Once in 2.5 years, once in 3 years. I mean, if he does it now, he's on schedule, right?
Exactly. So, we cleaned the core, we changed the filters, got rid of the, 70% of all dust is dead skin cells. So we got rid of that, and, they have a much better operating system, and it will last much longer since they were not restricting the airflow, which is really important. So, one thing that's important too is, when COVID first happened a year ago, a little more than a year ago, I was speaking to my wife about this and understanding how indoor air quality is so important. Just because your air is circulating inside the building doesn't mean you have indoor air quality that's where you want it to be. You actually need an exchange of fresh outdoor air with the indoor air, and you have an air turnover. But what I told her would happen is, a lot of people are thinking, as soon as the winter ends, you're going to see this really big downturn in the infection rate. And I said, actually, I think we're going to have an increased infection rate, but more in the Southeast, where they start to use air conditioning more. Because once again, as we close ourselves in our buildings at, during the winter months in the Northeast and the Northwest, down in the South, in Southeast, Southwest, they're going to close themselves in the opposite side of that coin.
Right.
And
It's
so
just whenever you're not really opening up windows and doors for additional ventilation, and it
yeah,
just so happens that the outdoor time in Georgia and Florida and Texas and these other southeastern moist and warm places, they go inside as soon as we hit this time of year, and they're inside for a long time. And a lot of people don't get that you have to clean not just the filters on some of these air handlers, like an air source heat pump, a single head air source heat pump. You need to actually clean the coils once every 3 or 4 years, because they, even with those filters, those coils get pretty clogged up, which, as Jim was just saying, reduces the efficiency of the machine, but also means that you're breathing that. Now, we must point out that both the heat pump head and a forced hot air system is a closed system. You are actually not bringing in any fresh air with those things. They're called recirculation. So if you're not getting, like, if you have a forced hot air system, I remember as a kid, the odor of that first day in the fall when it would kick on, that kind of warm bread odor, which actually is the smell of burning dust, right? So I have a very fond memory of the smell of a bad indoor air quality.
Yeah.
So those things are recirculation systems. So if you have a forced hot air system, then you should be having the entire duct system cleaned, I don't know, once every 5 years at the outside. And people don't ever do it. I mean, we've been in houses where we're looking down the register in a living room, and we just see, piles of dirt, and we're like, oh, when was the last time you had your forced hot air duct system cleaned? And they look at you and they say, cleaned?
Yeah.
So we got to be careful about that. So the indoor air quality monitor, just to close out that question, that it does relative humidity, it does temperature, it does carbon dioxide, and it does something called PM 2.5. That's picometer size, 2.5 picometers, which is a teeny size. But that's an important thing to know, because the 2.5 picometer size can not only go into your mouth and into your bronchia and into your lungs, but it's small enough to actually clog the alveoli, where that last bit where the oxygen pore blood and the carbon dioxide pore blood, or whatever part of the cycle you're in, transfer, and that can get clogged. Once that's clogged, that piece of dust, which is big enough to clog the entire alveoli, is gone, and it has to be destroyed and a new one grown in order to replace that. That's why if you look at pictures of lungs of people who have suffered from lung disease, if you get that under a microscope, you're actually seeing the clogging of those very, very small pockets that are necessary for the transfer of oxygen and carbon dioxide in the lung. So those are the four things that this monitor will tell you. And it has a couple of very cool graphics to show you, like when you get to a high carbon dioxide level or a high PM 2.5, the person starts out smiling, and then they're kind of with a green background, and then they get this kind of all the way down to the purple one where they're wearing a gas mask, and everywhere in between. So it's a lot of fun. It also reminds you that odd things that you wouldn't think would be considered bad indoor air quality events can be registered as that. A shower event can be registered on this machine as a problem, because you have a much higher water droplet ratio, and your relative humidity goes up. Now, is that dangerous? Of course not. You can take a shower and not get ill from it. However, it is the way that it registers and reads, the sensors read what it is that it's actually getting. It reads as a dangerous event. What is dangerous? Cooking. That is, oddly enough, without good ventilation, can cause a rise in the PM 2.5. So,
but at the same time with that, Chris, one thing that's really important, and I've been involved in several new house builds like this, where the house is made really efficient, really tight, and they do have some air exchange, but sometimes they don't, because they may get under one air change per hour, or right there around one air change per hour, when state code right now is 3 air changes per hour. ASHRAE 62 wants to see that anything below 2 air changes per hour is going to have balanced mechanical ventilation, not
Yeah,
just an
not just
exhaust.
extract, right? Yeah.
Exactly. But if you don't do something with that and you get this, I had a customer who had a huge commercial grade cooktop that he actually used. I mean, I've been inside some of these really expensive homes. You get all the Wolf appliances, Sub-Zeros, and they don't use them.
Right.
This gentleman is a chef, and he uses this all the time. His cooktop was 168,000 BTUs of gas that could come off there. So all that effluent, all that those items that needed to be exhausted, he put in a 900 CFM maximum vent hood in a home.
Can we put that into perspective? That how many dryers is that running at once, right? A dryer is, yeah, 3 or it depends on the dryer. They're usually around,
True.
between 150 and 200 CFM. So 900 CFM is like, 4.5 dryers running simultaneously.
Yeah, and so he had some really nice low volume, low voltage with fans that weren't as robust. They were efficient, but they were fans that would actually, when you depressurize that much, you're creating a vacuum, and it would actually cavitate or back up, stall out the actual intake fan, and so it would not be able to bring in the fresh air that's needed. And since it wasn't able to bring in the air, it couldn't exhaust because it wasn't getting the replacement air. It could not exhaust all of the effluent that was coming off of the stove. Added to that they had the house designed with a 68,000 additional BTU propane fireplace. Yeah. And so you add all these together, the building science wasn't being carried out appropriately, and that house would not have functioned. So we had to do a lot to get enough combustion air brought back in. I tried to convince him to go with an induction range, which is electric, highly efficient. It responds like gas, but the gentleman said, that would be a lot of pans that I'd have to buy to get one of those type of units. Well, he ended up spending $25,000 to rectify the indoor air coming in because he needed to have it preheated at certain temperatures. I said, you could buy a lot of pans for $25,000.
Even really nice pans.
Exactly. But with that, what we're trying to get to here is the fact is we are getting homes tighter by default because the products being used, the building wraps and everything else, you are getting a tighter structure from an air leakage standpoint. And thus you have to give more attention to the indoor air quality and how you're going to get that air to turn over with healthy air, get the stale air out, get the particle laden air out, but also get fresh air back in without losing expensive conditioned air, whether that's cooled or heated. And so that's kind of what we're thinking about here. We're also looking at, if you do correct these issues or you give proper attention to them, you're going to have decreased use of healthcare services and medications. Well, how can you promise that? I just know that if you keep breathing that same air, once again, as I said earlier, it's going to cause an effect on your health and your well-being. Right. And when insurance companies finally connect all the dots here and realize how important this is, and they are starting to, there's a lot of pilot studies going on to test some of this and what the relationship is to bad indoor air quality and to your overall health. Once they catch on and realize that the premiums or their exposure can go down, and as it relates to indoor air quality, if they improve that, you're going to see a lot more funding for this to happen and a requirement at the same time. But you're also going to have an improved quality of life. You're going to sleep better. You're going to sleep more soundly.
Absolutely. I just want to jump in and say we're not promising that.
Yeah,
What we're saying is that we are, as human beings, we are prone not to call our house the reason why we're not feeling well. We'll first go to I haven't been sleeping well, or I've been stressed at work, or one of these other reasons. But oddly enough, if you track these things, if you just take the data and you can correlate that, if you have something like the IQ Air monitor, you can correlate the information you're getting from that directly to changes in your and your family's health, and that is not a guarantee because every person is different and they can deal with different levels of bad air, as it were, without having a bad problem with it. But it is a pretty bad situation. And Jim was bringing up a very good point, which is we are, as an industry, as a builder industry, the construction industry of residential buildings, we are constantly moving the tightness, air tightness down. We're trying to get them tighter and tighter because one of the main ways to reduce energy use in a house is to reduce the infiltration losses. Those infiltration losses are very big if you're trying to maintain comfort in a house that's very leaky. However, once you start making houses tighter than that 2 air changes per hour at 50 pascals, then we need to start looking at bringing in a balanced ventilation, mechanical ventilation. But builders are not necessarily aware of that second part. They're like, oh, I want a really, really tight house. And we've been in a couple of houses, you and I, Jim, both, where we were doing blower door tests on new construction, where the house was clearly in need of a balanced ventilation system, but it was not in the budget or they hadn't thought about it. It's like, well, we're really glad that your house is tighter than 3 air changes per hour, but there's a danger zone here that we have to be really aware of. And it's easier to put these things in before the sheetrock goes up. After that, then we have retrofit options, but those retrofit options are great, but they're not quite as good as having a central unit. Having to put 3 sets of Lunos or the Zender Comfo Air 70 are great solutions for retrofits. But let's not turn our new builds into automatic retrofits, right? Let's try to avoid that one. And I'm really proud of our builders for having been able to break the nut, as it were, of how to make a building tight. Right now, we're getting builders who used to scoff at the idea of 3 air changes per hour or less, now just hitting it regularly. But we have to watch out for the flip side of that. The indoor air quality can be...
Exactly. And that is the big concern of mine and yours as well, I know. But even as we're trying to make buildings more efficient, and there's now federal money, state monies going towards weatherization, and it's great. And I was in a meeting today with Efficiency Vermont's EEN contractors, and I tried to ask the question, but I was on the road and Zoom wouldn't let me ask. And so anyway, I'm going to follow back up with that. But if we're going to be spending over the next, I think it's 2 years, 3 years, a $5 million nest egg, if you will, that's been given to Efficiency Vermont for incentives, part of that equation has to be addressing indoor air quality. If you take a building that has been inherently leaky, whether it's 1 year old, whether it's 50, 200 years old, and all of a sudden get really great numbers and tighten it up, you are doing a disservice to the building and to the occupants by not addressing the indoor air quality, because you're fundamentally changing how that house has been operating as a system. So then you bring to the table so many other contaminants that we haven't talked about yet. We did talk about vermiculite, we did talk about lead, we did talk about rodent leavings, if you will, but also you have CO.
Only in a roundabout way. We didn't actually say rodent droppings until just this moment, but there we go. It's been said. It can't be unsaid.
The gifts that keep on giving all year round. But the carbon monoxide that can exist from some of the appliances, fossil fuel burning appliances, and also should your wood stove tend to back up or whatever, because you get the house really tight, you have other VOCs, volatile organic compounds, that are introduced from the very beginning of new construction. And a lot of those take years to off gas. And most people don't know, in the first year in a single family home that's around 2,500 square feet, 500 gallons of water are going to be introduced into the airstream. And if you've got a really tight house, that's going to want to migrate from highest concentration to lowest concentration and then condense on the outside sheathing. And when it does, it can introduce a mold issue in a very short amount of time.
The first condensing layer, just pointing out to everyone to tie it back in with what we've already learned about building science. That what Jim is talking about is the migration of moisture from a higher density inside our houses in Vermont during the winter, and outside it's lower. So at that point, the water vapor will move through your walls, and if the sheathing is below the dew point, it can deposit as water, or sometimes as just directly to some kind of ice or frost. But then that will turn into water when we get to a warmer part of the year, and that can be dangerous. And if you don't have a good way to manage that moisture, in that first year, what's called construction moisture, the moisture that's in the wood that's used and the other products that are used, concrete, etc. That takes about 6 months to dry out of the house, as long as as long as the house has not got seven tanks full of fish or something, or a hot tub. But yes, that's a very important point.
Yes. But then also you have radon, and radon can exist in or be apparent in existing homes or brand new construction. In fact, every new home that we're a part of building at this point in time, we're future proofing it by putting the piping in to evacuate the radon should it be found once the house has tightened up and finished, I should say.
Should be standard practice at this point. Isn't, but should be standard practice.
Because that way, all you have to do is put a fan on to extract the radon out of there. Radon is what? It's a carcinogen. It's a cancer-causing agent if you're exposed for any length of time, and that's why it's really dangerous. But you could have houses right near each other. One has it, one doesn't. It doesn't really matter necessarily. So that's why you always have to test to make sure whether you have that or not. But that's another one, that if you got a really tight house, it's going to concentrate those levels in there and make it more of a hazard. And then you also have the whole relative humidity issue. Once again, if you've got a old farmhouse with a dirt floor, I heard a story from a gentleman just today who is into concrete, but he said he lived in a place where it just had a dirt floor, and then they went ahead and insulated the walls and didn't put a vapor barrier down, did not seal off that moisture. What did it do? It super concentrated all the moisture inside the basement and started causing issues where there weren't issues previously that they could actually identify. Yeah. So that's going to be a problem. And once you have higher levels of humidity in there, you're going to have a higher incident of then the other issues, the mildew, the mold, the rot. And then once again, you're going to be breathing that through your lungs, and that can actually be one of the contributors to health problems at the same time. Yeah. And another area where we find issues is in leaky or poorly ventilated attic, and in walls where moisture is trapped as well. And so what we find is, and I found so many of these attics where we get up there and it's black. There's black mold, green mold, white mold, whatever mold, all the molds you don't want. And you think, well, that's up in the attic. Why is that a big deal? Because when you have a porous attic that first allowed that to get up there, you then are still going to have some sort of circulation back into the structure, and those spores will find a way. And I know from a personal level, I live in a 1989 Cape, and before I did a gut retrofit, and before I understood building science the way I do today, my two older boys were just little toddlers at the time. And every year during the winter, when we started closing up the windows, they started having respiratory issues that we didn't know what was going on. The doctor didn't know what was going on. But you knew as soon as it started, the house started getting closed up, they started having these issues. As soon as spring came around, we opened things back up. It wasn't there. So one day I got up in the attic and found everything black. And somebody thought it was a really great idea to save $14 on an outside wall vent for the bath fan upstairs and just not put that in. Instead, just throw the vent tube right up into the attic. And it was also a very porous cape, which most capes are until they're retrofitted or they're built correctly. And so it was contributing to that problem. And so my boys were suffering respiratory issues. I've gone into other people's homes. And when we find this, I said, does anybody suffer from headaches? Does anybody suffer from, asthma issues or whatever? And the hands start going up. It's because it does have a contributing effect to the building occupants. And it's why it's so important to get it right. But also that mold is eating the structure.
That's a durability issue right there. Yeah, exactly. It is food. So even if you can do testing to prove that there is no spores coming into the house, at least you're certainly dealing with a long-term or even a short-term durability issue if you're not going to deal with that. Well, we're going to take a quick break. We're going to go and have a quick talk with Steve Spatz, pre-recorded talk. Steve Spatz from Efficiency Vermont. And when we come back, we'll chat a bit more, and then we're going to look at what's going on at 10 Old. And then finally, we'll get our interview about this really fascinating new wood fiber-based insulation that has been around for years, but is now going to be made available locally. So give me just a second to bring up this video, and I will get it started. Hey, this is Chris West from House Calls Vermont, and we have with us our good friend Steve Spatz from Efficiency Vermont. Steve, welcome back. It's been a month and a half or so since we had the last radio show when you could call in, and it took us a while to get this set up right. So thank you so much for taking time out of your day to join us. How are
Happy to be
things?
here, Chris. Good, good. Happy to have better weather our way here now and enjoying some spring and busy spring. It's early summer at that as well. Lots going on out there in the world of construction.
That
at the
is
moment.
absolutely for sure. We did a whole show last week on materials prices, and that
Yeah.
was that is a topic
Not
on
great.
everybody's mind. No, you know, 5 times what a 2x4 cost a year and a half ago. It's a bit nuts. But can you give us an update on where things are at with the home performance of Energy Star, which most people know and relate to as an energy assessment or energy audit? What's going on with the where are we at right now with the Efficiency Vermont rebates for that?
So Efficiency Vermont's home performance with Energy Star program ongoing, and rebates or incentives available for doing air sealing and insulation measures in existing homes. That rebates of up to $1,000 or $3,000 depending on household income. So we'll cover 50% of the project cost up to those caps, depending on household income. So we have a contractor network that are specifically trained in building diagnostics, health and safety, combustion safety, big picture thinking about how to appropriately address building envelope improvements and equipment replacement improvements as well.
And that's the EEN, right?
That would be our home performance EEN contractors. So all Building Performance Institute certified contractors, contractors that have a partnership with Efficiency Vermont and are the exclusive offer of the incentives by working with them. They also have access for their customers to the home energy loan and the business energy loan, which are two financing packages that are available through Opportunities Credit Union, Vermont State Employees Credit Union, and NeighborWorks of Western Vermont, where homeowners and small business owners can borrow at very low to no interest to support weatherization and other like equipment replacements and things like that, efficiency measures on their homes and businesses.
Great. Oh, that's good to know that there's still money there. I am a big fan of making the amount of money available dependent upon home income. I think it's an equitable way to spread the money that you get from as Efficient Vermont to do those programs. So I'm very glad to hear that those are in place. Are there
the state of Vermont is as well looking more at those issues. A lot of conversation in this past legislative session, bills that were proposed, the governor himself putting emphasis on weatherization and improving those outcomes for middle income market rate of Vermonters, and trying to break down some barriers to be able to get access for more people to pursue this work on their homes. So some more attention being paid at the state level as well as the federal level. So hopefully more interest and attention to be paid towards this in the months and years to come as well.
Yeah, I hope so. We're actually going to be speaking to one of the weatherization managers at one of the weatherization assistance programs, which is not market rate. So that's
correct.
That's going to be WAP money, which is a weather assistance program. So are there any programs that are going on as far as individual like mechanical replacements that are in there? I know that for a while there was a quite a nice rebate for, I think it was air sourced heat pumps that do domestic hot water. Are there any of those programs that are still available?
Yeah, all that is still ongoing as well. So those are product rebates through the supply chain, so through participating retailers and suppliers, and all heat pump categories pretty much are covered on that. So we have rebates on mini split ductless heat pumps, on ducted heat pumps, whole house heating, cooling systems, compact ducted, which are smaller duct systems for heat pumps, and as well as you mentioned, air to water heat pumps as well, which we're getting a lot more attention right now, a lot of interest around the state in using the heat pump technology for creating hot water for standard hydronic heating. So radiant heating, low temperature baseboards can be used for creating domestic hot water. Heat pump water heaters as well are another product that has rebates available for it as well.
Nice.
And more things being done around building controls and automation and things like that, both for residential and for commercial use, and a lot of work in the commercial sector as well on HVAC controls, trying to get more out of the systems that exist and have them better integrated with modern equipment and technology that's coming into play here, such as heat pumps.
Great. So if you are listening or watching, and it's not just listening at this point, and you have a project and you'd like to know more about either the EEN, that Energy Excellency Network, and or the Home Performance with Energy Star for energy audits for improvements on your house, or if you're interested in knowing more about any of these individual rebates that are based on the what did you say, market supply chain, was it?
Yeah, basically any of those products I listed, any of the heat pump equipment products, are rebates available from the retailers and suppliers in the state that carry that equipment.
So once again, where do we go to get any of this information or to talk to an expert who can lead us through the right path forward?
You can go to efficiencyvermont.com, and we just recently updated the website, so it's a whole new look and some better navigation around the website as well. So head on over there and you'll be able to explore all the different programs, services, information on equipment, energy efficiency in general, and be able to connect with whatever answers you're seeking from us on that end.
Perfect, Steve. Well, thank you so much for stopping by, and we'll start getting you in the process so that we get these videos done a little before the day of a broadcast. But I want to thank you again, and we here at House Calls Vermont are huge supporters of Efficiency Vermont, so we want to make sure that your message is still getting out there.
Well, thank you, Chris. I'm glad to have you guys back in the public here. Good on YouTube, so look forward to seeing where this goes and continuing the conversation with you.
Great. We'll see you next week then, Steve. Thank you so much.
All right. Take care, Chris. Thanks.
Okay. Bye.
Bye.
So, Jim, there we have it. Steve Spatz back on the airwaves. Thank goodness.
Yeah, definitely. Great to have him there.
Yeah, and we'll be getting regular updates from him. So why don't you just do me a favor and vamp for a second while I get the update from 10 Old Stage ready to go.
Vamp. This is fun. Anyway, some of the things that we're going to be, looking at are where are some of the other issues that we could be finding in the house and what we need to look for. Certainly your combustion safety equipment, as we said before, sometimes it could be backdrafting. Backdrafting is when the exhaust that normally goes up, usually just through an atmospherically vented chimney for a fireplace, or chimney or exhaust for an actual oil-fired or propane-fired, natural gas-fired element. That's the draft isn't strong enough as compared to some of the air that could be pulled back the opposite direction. So let's say you have a very weak draft going up the chimney, but then you start turning the high efficiency dryer on, bath fans, vent hood for the kitchen, that can actually pull things back down. So if you're going to be tightening up the home, even before you do tighten up the home, it's important for you to check these the strength of the draft just to make sure that those are going to be strong. Otherwise, it adds those contaminants and really toxins to CO, carbon monoxide, into the environment. You also want to look at same thing could be happening for wood or pellet burning units for particulates. You could think about installing a combustion air intake device, which is actually an air line that will come from the outside into the firebox of the heating appliance, or next to what they can call a fan in the can that goes next to an oil-fired furnace or something like that, to give fresh air to the unit for combustion instead of drawing it from other parts of the house or not having enough and having that backdrafting to occur. You also want to check for gas leaks inside the house. Many times, one time Chris and I were filming, but we found this in other homes that we were filming, and on the inside of a friend's home where we were filming an energy assessment, home performance assessment, we found 2 gas leaks, one outside the home and one inside the home, which you don't want to go looking for that leak with a match or a lighter. But once found, your whole world changes. You can have asbestos concerns as well. Vermiculite insulation is one of those, which is a tan, granular, crystalline looking type
Looks
of
kind of
insulation.
like mica.
Yep, exactly. Very much. Yeah, great description. You can also have in the old 8x8 tiled floors. For some reason, that time period, that was the dimension that was being used, and a lot of times that would have like a black mastic, and you could see that there was asbestos behind that. And then also sheetrock, mud and tape, caulking on the interior and exterior. I mean, asbestos was used in so much, even talcum powder. Which J&J, Johnson & Johnson's trying to get out of the lawsuit right now because of that. They used to include asbestos in talcum powder, so it was in a lot of building materials because it was known to be, fire retardant, and that's one of the reasons why they used it so readily.
It ends up that it's the shape that makes it so good at that, right? The way it dissipates. So a carbon tube, like a buckyball tube, one of those extruded carbon tubes that they're talking about, those filaments, would also be something that would be good at dissipating heat throughout and it's known for that. But at the time, we didn't know that asbestos was also something we'd be careful about for lungs. So I think I've got this ready to go. We're gonna throw it up here and see how it flies, and hopefully it'll fly just fine. And let's take a look at our update from 10 Old Stage. Okay. Hey everybody, this is Chris West from House Calls Vermont with our weekly update on what's going on at 10 Old Stage. And today we're upstairs on the second floor of the brick part of the building. And I just wanted to describe to you what it is. I've got some great videos which we can look at some point. Street traffic. But basically, this was a cape. So the roof came down pretty much like this and ended up at where we have the top row of bricks at an 8x8 beam, and that was it. So all of this headroom didn't exist. As a matter of fact, the floor for the room didn't start until here, and so we only had about half of the space available, possible floor space available. So what we did is we pulled off the roof. We still have some very cool pieces we'll look at in just a second. And then I built this cap. I'm calling this a cap. It's the top two rows of brick, but I'm using a Portland cement mortar. The original house is so old that it's using a lime-based mortar, and that just crumbles and falls apart as soon as you start moving it. As long as it's stable and not moved, it's fine, but the second you start moving, the whole thing just falls apart. So we put this cap on top in order to tie in all of the bricks below it and give us a good foundation for our mud sill. Now you're seeing a bunch of wood on top of this. I'm just going to move over here so you can see. This is the mud sill, and using classic bolts, we just bolted that to it. So this is pretty firm. Last week when I was telling you about the pony wall that we're hanging the outside 3/4 inch PT on, this is that pony wall. It's about 6 feet tall. It takes us from about the 24-inch mark or 21-inch mark all the way up to our 8-foot mark. And so that is what we call a pony wall. This is replacing, the old roof. And then we have just a flat ceiling. We got an energy heel up here. That energy heel is going to give us 24 inches of insulation all the way to the outside. And then we have our window bucks. And so the downstairs window bucks are being mortared into place. I showed you that last week. And these ones don't have to be, right? This is going to be a double stud wood wall. So the plan here is to add a layer here, another wall. And that wall is going to give us basically 8.5 inches of dense packed cellulose, or rock wool, depending on where we want to go. Then outside that'll have the 5.5 inches of polyiso. So we have, we're talking about like an R60 wall here. And I'm only doing that because I've been in houses where it steps in like that. I just don't like it. You put your bed up against it and there's this weird space between the top of the bed and the wall. It's a ledge all the way around. Some people think that's great, but I'm not a big fan. So we're just going to make this full of insulation, and then we're going to come in with a 2x3 to create a chase, and that chase is going to be where our services are going to come in. and that will end up being where this stops. And when we're installing, we're going to be doing a window install. It's called mid-wall window install, which means that while usually you would have a window installed proud, which is where the window sits to the outside of the structure, we're actually going to be putting the window about halfway through. And we, if you go back and look at our show, or the radio show, we were talking about mid-wall installation, and that's what we're going to be doing here. And one of the benefits of mid-wall installation is that the heat losses of window are the window pane, that has a certain amount of heat loss, the window frame, that has a certain amount of heat loss, the materials they use for connecting the pane to the frame, we call that the size spacer, and then the contact between the actual window frame and the wall. Those are all possible places for heat loss, and you can do a bad job of it, you can do a good job of it. But if we're going to have this entire thing filled with insulation, then actually by putting this in the mid-wall, I have, if I were to just look through, I'd have window frame, a little bit of foam to fill the gap, the rough opening, and then I'd have this, and then on the underside I'd have insulation. What that means is that the heat loss will not have a direct path through a thermal bridge. It's going to say, where am I going to actually lose my heat through? I've got this 3/4 inch plywood, I've got the frame, I've got the insulation. Well, it's obviously going to go through the frame as the lowest heat resistance, the highest conductivity. But if I were to put this window all the way on the outside, and the outside was, say, a 1/2 inch or 3/4 of an inch or even 1.5 inches of airspace, because I have that rain gap, and then I have the insulation, so only half of this frame would be over insulation, then there's an easier path for heat to run from the inside kind of diagonally through to that cold that is the strapping for the rain screen. So this installation, the side install of a proud window, is almost always not as good as the side install or the linear heat loss of a mid-wall installation. So that's why we're going with a mid-wall installation. Now I just want to give you a bit of a look at the windows we're actually be installing. We had an interview last week with Darren Macri of Wythe Windows. I want to show you some of his windows and why we choose them. So these are the windows. They're not installed. I've got 2 types of windows here. They're all tilt and turns. One is just a straight up tilt and turn, and the other is a tilt and turn with a fixed window mold to it, right? This connector is called a mullion. First of all, this is a really robust frame material. This is a UPVC, which is much more robust than the PVC windows that we have in, say, an inexpensive, big box store-bought window. After 10 years, those windows of regular PVC, as we all know, the PVC gets brittle. It gets brittle from outgassing. It gets brittle from UV, from the sun beating on it. Well, this is a UV supported PVC. They have installed versions of this in Europe that are 20 plus years old, and it's holding up just fine. It's a very sturdy material. Then we have a triple glazed window. Triple glazed window has a U value of the window itself of about an R8. And then we have where the window and the frame come together, that size spacer, and this is a super spacer, so it has a very low heat loss at that particular junction. I'm going to open this up now just to show you the various air sealing. One of the things we love about these windows is that they are amazing air sealed windows, right? So when you're looking at a double hung, you have a track on either side, and the double hung slides up and down. In order to slide, that has to have a gasket, and that gasket is not as effective as a held-on seal with a lock. So you're constantly losing air when a wind blows against your house, or just because of increased pressure inside the house. through that gap, right? There's just a gap there. You can even, when we have the kind that you can tilt out and then you can wash your windows, which was seen during the 70s, 80s, and 90s. It's a really big deal. You can wash windows. Well, that increases the air leakage of the window. And when we're trying to make our houses tighter and tighter, then the window becomes an important part of that. And I just want to point out here that this window has got 3 different seals. We have a seal on the actual door of the frame. And then in here, you can also see we have 2 secondary places where the step up of the frame meets this gasket. So we have 3 gaskets. And these 3 gaskets are held in place by 5 locking positions. We have the 2 hinges, and then we've got these 3 locking positions. So when we're locking this down, I'll just like this. So when we do that locking bit, I've got these 2 hinges are already holding it together. But here, here, and here, it's clamping down those gaskets against the frame, creating an incredibly tight connection. So this is going to be a lot less leaky overall than through the window itself than a double hung or even a casement, which itself only has usually 3 points of contact. The downside with casements also is that casements have a lot of machinery inside the frame, and that itself is a thermal bridge that can cause long-term durability issues. So this is a tilt and turn. The nice thing about a tilt and turn is it does the turn part, but it also has this other function. If you put the handle up, it does what's called tilting. And this tilt allows for you to have the window open to get a 5-6 inch gap at the top, just to get some ventilation without necessarily having the window all the way open. Downsides to this window, the biggest downside to this window used to be price, but right now White Windows provides a passive house level window, an R7 window that is a similar price point as your standard but good quality Marvin's Pellas or Andersons. So this is an amazing advance in technology that we need to embrace. And when we do the actual install, we'll give you a look at exactly how that goes, that mid-wall install. But here's the technology we use for that. The actual extrusion has a profile, and we get these clips. And these clips then just fit into the profile, just kind of like this. And you go zoom. And once that's done, I think this height needs 4 from the top to the bottom. Once you get it into the rough opening, you can bend these out and then attach these to the wall, and that's what keeps the window in place. The whole flashing detail is a big deal because it's mid-wall. That's one of the downsides to the installation, is that the install requires a lot more attention than a flange, where you just throw it up, put some tape over it, nail it in, and we're done. So it does require a little bit more labor, but overall the performance, the difference between an R3 or an R4 window and an R6, 7, or 8 window is obviously going to pay for itself over time. Also, one thing I haven't mentioned, but is really important, is with a triple glaze window, you're not going to get heat loss from the inside surface of the window. So usually in the winter, if your heating system is not on, or even if it is, we usually have radiators under windows because windows are thermally not very good. So that's why we add heat there, because we know that we're losing a lot of heat, and we want to be comfortable in our houses in winter. So usually in the middle of the winter, on a cold day, if you start from the inside surface, like you're in a room that's near the wall, near the inside of the building, and you walk towards a window, you will notice yourself getting colder. And what that feeling of cold is your body is radiating heat, and that heat is being drawn to the window, and that window is creating a heat loss. Well, and the inside surface temperatures of those windows can be in the 50s, sometimes in the 40s. This window, with a triple glazed window, your inside surface temperatures usually don't get below 60 degrees and sometimes as high as 63 degrees. And with that high of an inside surface temperature, as you walk to it, even without the radiator under it, you're not going to feel a heat loss. So these windows are supreme as far as comfort is concerned. So that's where the window talk today, here at 10 Old Stage. A little information about our building, about the pony wall, and about where we're going to be putting our windows, and a good look at the white window Stuyvesant, which is one of the various options you can get. So thanks for watching, and we'll see you next time. That was the update from 10 Old Stage, looking at windows and the window bucks and how we're going to be doing those installs. So that's always exciting to see. And we'll be when we do the actual install, we'll do a whole bit on where we're installing them, why we're installing them, and the process to go through to make sure that we give locations where the weep holes can get water out of the frame, which is something very specific to this type of frame, but also to make sure that we have vapor open tapes that we're using, and we'll share with you the products that we use for that and the actual install. Now we are at about 8 o'clock. We're about an hour into the show, and we want to start off our interview. Our interview today is with Scott Dionne. He is the Chief Marketing Officer for Timber HP. Timber HP is a product that is a wood fiber based insulation, something similar to what we know as either Echo 4 from Quebec, or Gutex, as we've seen it imported by 475 over the past 7 or 8 years. And Timber HP is building a factory, or they're repurposing an old pulpwood factory that used to make paper in Maine, to use pulpwood and leftover from wood from other processes to make insulation. And that insulation will be available starting in the beginning of 2022. And when we're doing the interview, we'll be able to hear from Scott exactly what that is. Hi everybody, this is Chris West from House Calls Vermont, and today I am going to be doing an interview with Scott Dionne. Scott Dionne is the Chief Marketing Officer for Timber HP, and Timber HP, from what I understand, is a company that is developing a factory in Maine that's going to be producing a wood fiber insulation material similar to some of the products we've seen on the market like Echo 4 or Gutex. So Scott, welcome to House Calls Vermont, and thanks for taking the time out to speak with us.
Yeah, thanks a lot, Chris.
What is the product, and tell us more about what is going on in the factory and development, and just we want to know more about this this new insulation that's going to be made domestically, that until recently we've only been able to get from an international supplier.
Yeah, so of course, wood fiber insulation is certainly not a new technology. It's been on the market in Europe for well over 2 decades. There's 15 production facilities in the European market, with 4 more production facilities coming online in the next 2 to 3 years. Right now in Europe, wood fiber insulation accounts for well over $700 million in sales into the European Union. Again, in Europe, if you know a bit about construction in Europe, most of it's masonry, with only about 20 to 25% of residential construction being wood frame. So really, when we talk wood fiber insulation, it's insulation for wood frame construction. There's 3 types of insulation, and we'll be producing all 3 types in Madison, Maine, at the former paper mill. And we'll be producing a loose fill, which is analogous to cellulose or loose fiberglass. We have a batt product that's a press fit batt, similar to the mineral wool products that are on the market. And we have continuous board insulation to kind of take the place of exterior board, foam, and mineral wool. And the board product is really the product that has been imported from Europe by some folks in passive house design, and some folks who are focused on low carbon impact materials. So, but we'll have all 3 about wood fiber insulation production in the United States or North America, primarily the U.S. and Canada. We're going to be the first producer, or about a third of what they are in Europe, and our energy costs are about a half. And anybody in the building industry right now thinking about wood costs being low are probably not thinking that I know what I'm talking about, but the
Actually,
wood that we're going to be
actually, last week we had a whole discussion about the price of logs is about as low as it has been in a very long time.
right. Yeah, so I mean, loggers are actually getting paid less now for saw logs than they were pre-COVID. So the residuals are what we're using. We're using leftovers from lumber production that have typically been marked for paper production. But if you look at paper production domestically over the past 5 or 10 years, it's a pretty tough landscape because we're not using nearly as much paper these days. So in the state of Maine, we've lost 6 paper mills in the past 5 years. So all of those low value residuals have to go somewhere. And wood fiber insulation makes perfect sense because it would be taking these softwood species agnostic residuals and turning them into a high value product. These 3 insulation products, and introducing them to wood frame construction throughout the United States and Canada.
So you're talking about having product. Right now you don't have any product available. Right now you guys, or do you have, I remember you were saying that loose fill was going to be the first product available and that was going to be happening sometime this year. Do I remember that right?
Well, right now we're finishing our engineering, which is pretty considerable. So we're completing our financing of the project, which is a $120 million build out of this project. And we are finishing the engineering, and we'll be moving very shortly in the next month or two into construction. We have our board line to produce the board product line actually is sitting in Maine. We purchased that from Home and Eat in Germany. It was a used board line produced by Diefenbacher, and Diefenbacher has been hired to upgrade the board line for our needs. So they're one firm that's working on this project.
A board line, you mean the manufacturing machines that make the board, right? Just to clarify.
Yeah, correct. So the Diefenbacher line will create a monolithic board product that is from 1 inch thick all the way up to 10 inches thick.
Wow.
It would be similar to the board products that you've seen produced by Styco and Gutex.
Okay.
Our batt line is a domestic producer, and the loose fill packaging is an equipment supplier who produces packaging equipment for the cellulose industry also.
Okay, so
we're completing all of that engineering. Completing all that engineering, and then we'll be pivoting right into building out the facility, which most of the work has to be done ahead of time when it comes to engineering, understanding how the equipment's going to be produced, how it's going to fit in our facility. And then the loose fill product line will be coming into production the second quarter of 2022. And the batt line will be coming on late third quarter, early fourth quarter, and the board line will be coming on late fourth quarter, early first quarter of 2023.
Okay. So what the first thing that, I mean, availability is of course very important when we're talking about a new product, but also availability, not time-wise, but price point-wise and local distributor-wise. So here in northern Vermont, but just say Vermont in general, when we were talking initially, you described the distribution network that you're going to be working with. Can you talk a little bit about that?
Yeah, sure. So independent lumber dealers really focus on added value. And that's really what our product line is. We want people who are going to help provide solutions to the market. And that's really what we're doing is we're taking this proven technology from the European market and we're adapting it to codes in the United States and how we approach the build. With that, it's, looking at supply chain and how we buy our insulating products. which will be able to follow those pathways, independent lumber dealers and having a two-step distribution partner with warehouses across the Northeast. But the bigger question on supply that you bring up is pricing. And for us, due to the fact that wood prices are a third of what they are in Europe and energy is half, in Europe, the product enters the market as a premium that's focused primarily on the sustainability market. Whereas for us producing domestically, we're able to enter the market on price point with all of the common insulation products that are being produced today. So we'll be able to approach the mainstream construction market without simply having to follow niche pathways to market for sustainable building or just passive house. We'll be able to open up this technology to scale so that we can have true impact in the built environment. And for me, my background is mainstream construction. I've been in the lumber and building materials industry for the past 26 years. I started at the local lumber yard and worked through distribution. I was vice president of operations for a multi-chain retailer. For me, price is important, but performance is the absolute key. This product has to perform as well or better than all the other insulation products on the market. Otherwise, nobody is going to give it a second look.
Absolutely.
So price and performance. And with wood fiber insulation, it comes down to fire and water. As soon as you get people to understand that the product doesn't burn, our loose fill and batt product are treated with boric acid, which is a fire retardant. It's also a mold and mildew inhibitor and a pest deterrent. But we've tested European product with UL and ICC. The loose fill and batt came back with a Class A flame spread when looking at ASTM 4. The board product typically doesn't even have a flame retardant in it because if you think about what the board product is trying to replace, it's trying to replace foam, EPS and XPS and polyiso, which all of those foam products will melt and many would ignite, but foam products are treated with flame retardants. But with the board product, not treated with flame retardants, we've tested the European product with ICC and got a Class B flame spread on 2 different densities of product. So when you talk about fire, that's really what you have to look at. And if people realize that the product's not going to burn, and I have videos that I can share at a later date, but with water, we're talking about creating vapor open assemblies, so we're not trapping indoor humidity in the built environment in assemblies. But also with the board product, it's so unique. It's vapor open, so it allows indoor humidity to exit the built environment. It's hydrophobic, so it repels bulk moisture during construction, and if the cladding were compromised. In Europe, they'll actually give you a 3+ month warranty of board product installed in roofing applications. So we see the board product primarily being installed in sidewall applications. Right. It'll repel that bulk moisture, and it's hygroscopic. So if it does get saturated, it'll spread that moisture out through its entire surface, and it'll exit the product when conditions allow without changing it dimensionally, which is extremely unique. So if the product performs, then we could start getting in, and the price is competitive with all the other products on the market, then we could start talking about the HP. So if you look at timber HP, HP means high performance first, and it means healthy people and healthy planet second. And for healthy people, if you look at the folks who are installing these products, they don't have to worry about the fibers being trapped in their skin for 2 to 3 days.
Just the irritation of mineral,
And you don't have to worry about what you're breathing in because it's sawdust.
Yeah.
And on the healthy people piece too, we're creating built environments that are vapor open, that are not trapping humidity in the built environment, causing issues with mold and mildew and allergens.
Exactly.
And creating safe spaces acoustically. Very few insulations perform any better than wood fiber insulation. Though we talk so often about thermal applications because we have a cavity insulation, a continuous insulation, and blanket insulation. A lot of people forget about the acoustic merits. On multifamily especially, they're using 3 times the amount of acoustic insulation, thermal insulation.
Yeah.
So there's a tremendous opportunity for wood fiber to be used in those applications, especially with the fact that it has a safe flame spread rate.
Right. Right. And I've worked on a number of multifamily projects where the sound attenuation between units was easily as expensive as the exterior wall insulation. It's a very important part of that making sure that people are comfortable living in these close environs and don't feel like they're sharing each other's information unnecessarily. So
Right.
I love the great laying out of exactly what the product is. And I love the idea that it's going to come in at a good price point. So one of the things I'd like to do is when the products become available, I'd like to set up a demonstration here in our area with the home builders, with Vermont Passive House, with members of the Efficiency Vermont Energy Excellence Network, and really get people to take a look at this product as an alternative to the mineral spun, whether it's fiberglass or mineral wool, or these plastic insulations, which are problematic not just because they burn and not just because of all of these agents in them, but because just having them in the ground causes microplastics to be shed and put into our watershed. And we're just starting to understand how dangerous microplastics are. So this is a very important development. I'm all for getting towards a house that if we stopped touching it would rot into a non-toxic heap after 50 years, right? It's the non-toxic being critical in that discussion. So I appreciate that as well. Are you all going to be doing an opening? Is there some kind of gala going on to celebrate the start of the like an unveiling that we can expect to get an invitation to?
Yeah, no, absolutely. I mean, we're taking it a step further because really when it comes to sales and marketing, our focus is all embedded in education. Our boots on the ground selling this product are really just going to be support people to the paths to market. And those boots on the ground are going to be building science experts, just helping support the construction industry. And, we want to be able to answer the questions about different assemblies for the market and really showing people that this product line is a drop-in replacement for the products they're using these days. And with the loose fill product, you don't have to go out and buy a new blower. Actually, to dense pack the cavity, they have to put less density of wood fiber in the cavity to achieve the same R value as other loose insulations that they're using. That product is a press fit install similar to the unfaced products that they're used to using. And the board product has greater compressive strength and, a lot of the continuous alternatives out there, so they don't have to worry about, shimming their batt and rain screen for a day to try to get their cladding to sit flat because it has greater compressive strength.
Yeah.
But the education piece is so crucial to the point that we're creating a MAD lab in our production facility, MAD because we're located in Madison. And that lab is really a cross between a physical chemistry lab and a residential construction lab. So if folks want to come and take a tour of the facility, that's great. We'll have educational opportunities there also. But as part of our marketing efforts, we're leveraging that lab to educate visually the construction market and create resources for the construction market. Behind the scenes, we're building out our website to be a resource center for the industry on building to code and beyond code using wood fiber insulation.
You brought up the building science aspect of it, and of course, Jim Bradley, my co-host, and I are all about the building science. What is the density that the dense pack is for the loose fill material for a wall?
So with cellulose, we talk about 3.5 pounds per cubic foot for the most part. With wood fiber from our R&D testing, we say there's a 20% deduct there. Whereas if you look at the European market, they don't dense pack to the densities that we do stateside. But for us, we want to be able to dense pack to a point where we're maximizing R value, maximizing air and the insulation itself is self-supporting. And we've been able to replicate that at value. We have an independent lab that's testing density to R value, so that we're not just transposing numbers from the European market.
Right.
So, for our loose fill product, it's all borate treated, and we use about half as much borate as cellulose because we introduce it in the wet phase, and that completely encapsulates the fiber. And, being able to create assemblies where you don't have to worry about any of the leaching of the flame retardant off the product is pretty crucial when you start looking at, these wall and roof assemblies that may have interior humidity accessing the assembly.
Yeah.
And for us, the ability to use less volume, even though we're price competitive per pound, we're actually going to have greater coverage per bag. So
your overall coverage price will be lower. Yeah. And we've been speaking also about the vapor openness of the product. Can you give us an idea of what the perm rating is for the board? I guess batts are a bit less important on that side, but
yeah, I mean, depending on the density, you're somewhere around 40 perms per inch.
Very high.
The density that we see entering the market is really, the two common densities that are coming out of Europe for the most part for higher R value dry process insulation. So 110 kilogram per meter cubed and a 140 kilogram per meter cubed. Though greater densities exist and we can produce those. Ours would be a blend of those two densities to maximize compressive strength and maximize R value. So we might be just a little bit under 40 perms per inch.
Okay. That's a great number. Absolutely high vapor open material. The exterior insulation, you said you're going to the exterior rigid. You said you can go from an inch to 10 inches. What is again the R per inch? I thought it was comparable to like a rock wool. It's in the 3.8 range, 3.5 range.
Yeah, I mean, I think the sweet spot for us for the compressive strength is going to be 3.7, 3.75. Okay. For our 1-inch product, we want it to be at 3.75. That way we can address climate zones that are just calling for, that R 3.75 continuous, and that way you can access that with just a 1-inch. And then our 1.5 inch will be beyond an R5 per board at 1.5 inch. So it is comparable to other open cell insulations that are on the market. I tell people that it'll be 3.7 to 3.75 while still maintaining a compressive strength around 10 psi.
Okay.
Because I think that's the sweet spot that people expect. XPS, you have to have at least 10, 15, 20%, whereas a lot of these alternative insulations can be like putting a sponge on the outside of a building, and you just don't have the compressive strength there.
Right, you're deforming the material when you're putting strapping on it and things like that. Yeah, no, right. I appreciate that. That's not something we prefer doing. I mean, we've dealt with it. I've used with exterior rigid rock wool in the past, and that that does have the downside that it isn't really rigid. It's really kind of a hardened batt product, which is a fine product, and it does certainly have its places. But I love the idea of having something that does not have such a high embodied energy as any of those products, and that also is from a renewable source. I mean, when we start talking about making some of these products, these are not renewable sources. So it lightens my heart as a ecologically focused building science consultant to be able to hear about American products that are doing what we've been expecting European markets to provide for a long time. And some companies like 475 have done a great job at being the outlet for those types of products in our market, but we really need domestic production. We can't go for much longer just saying, it's okay to all that bunker fuel that we're burning to bring over carton, loads and loads of this stuff is not something we have to take into account. So I really appreciate what you guys are doing. It's very exciting for us to hear that these products will be available starting first quarter 2022. So we're talking, a year, a little less than a year before the loose fill product would be available. So just let me remember this right. Loose fill and then rigid and then batt is the process that we're talking about on the release.
Well, it'll be loose fill, and then batt, and then board.
Oh, and then
yes.
board. Okay. So just think getting denser as we go. Okay, that's
Yeah, you're exactly right. The batt's about 50 kilogram per meter cube, so it's just getting denser, working our way denser.
okay. Great. And when we get closer to reveal day, then I certainly would like to have you back on and talk about the distribution availability here, because I know you said that you were already in discussions with a number of lumberyards here in our market. Fortunately, Vermont has actually is an interesting market for a company like yours, because we have quite a high density of builders who are trying to do that right thing, who are trying to use these alternative and new products, which we hope will be quickly adopted and become the standardized use or materials of use in the future. So Steve, thank you so much for taking your time out to come. Is there anything else like a website? We're going to be asking you for a bunch of links to videos, links to things. Those will all be in the description of the video. And is there anything else you wanted to share before we move on with our day?
No, you can check us out at timberhp.com and learn a little bit more about us and our product line, and you can sign up for the consumer newsletter, which we send out on a monthly basis, and it just keeps everybody apprised of what's happening in Madison and where we are on the production schedule.
Scott,
Right.
thank you so much for your time today, and we'll be speaking again soon.
All right, take care, Chris. Thank you.
Okay, well, there we have our interview. That was Scott Dionne of Timber HP, a fascinating product with lots of potential. Local distribution. The loose fill will be available starting in the first quarter of 2022, with then batt material in the second quarter and rigid in the third quarter. And price point comparable to comparable R value materials, and could be used instead of a rigid plastic type, an XPS or an EPS. Certainly much more friendly environmental product, and does carbon sequestering. And speaking of carbon sequestering, I was speaking to or emailing back and forth with Jacob Rakusin, one of the co-owners of New Frameworks. Jacob will be doing an interview here the end of June, and we'll be talking about embodied energy, carbon dioxide loading, carbon sequestering, which is where you whenever we build a building with carbon-based materials, including wood, but also this type of wood-based fiber insulation, that carbon dioxide is taken out of the cycle for now. So, and that's called carbon sequestering. So, Jim, there we are, episode 4 in the can.
Yep, I have several thoughts on the previous. First of all,
please.
Carbon sequestering. Why don't they call it a carbon sink? Make it easier for spelling. Challenge. Anyway, but for this product, several things came to mind, because one thing that's we see in the building science industry is that the technology, sometimes the science, is outpacing the functional tool-based side of things. Because I've run into this myself when we were trying to install more and more insulation on the outside walls, which, if you listen to the Building Science Corp, John Straub, Joe Stiebrick, those individuals who are the gurus of our industry, just a few of them, they would say that the perfect wall system presently is to have a stud cavity that can be used as a service cavity on the interior of the wall, and then the outside is where your insulation is going to be.
Right.
So the higher R value you go with, because if you go with this product, it could be an R40. If you use 10 inches, how are you going to hang that?
Yeah.
Because the largest size screws that we presently use are going to be 10-inch. Now, granted, you can go ahead and make larger ones, but then you go thinking about, okay, fastening the siding on, especially a heavy cementous base or wood type siding. How are you going to fasten that? And from an engineering perspective, the downward thrust or force of that static dead load are you going to have to build a ledger underneath at the bottom course to hold everything
Hold
up?
it up. Right.
Yeah, there's just a lot of, and the tools too, because I was doing the South Hero Library, and I could not find a siding nail that was 4 inches long, and that's what we needed to appropriately fasten everything. It went up to, I think 3 was the maximum. So the tools are going to have to catch up because the building science is there and it's going beyond, but the tools are going to have to start to catch up as well. So those are some considerations that I had with this: is how are we going to mechanically fasten this in a vertical installation profile?
Yeah, the buildability part of a 10-inch. Although I think what you were saying is what I would more expect. If we're looking for an R40 wall, doing R20 in a 2x6 cavity, and
Yep.
then an exterior of 6 inches or something to balance that out is an option, or 5 inches, and we'd have to see how that plays out.
And I do think that this product can be a great product, especially since, once again, he's using the residuals of the lumber industry. That is the leavings, as Jethro would say, once again, the leftovers. And that's a product that is being repurposed because the pulp, the paper industry doesn't need the same amount of pulp anymore. It's not producing as many newspapers,
Right.
and so, or circulars to go out in your mailbox. But
And we also recycle paper at a much higher rate
yeah,
than we do glass or plastic, which we almost don't recycle at all.
yep. And so with that, having another product, this can be environmentally friendly. A lot of effort to produce it has already, been invested, from the growth of the trees, the harvesting of the trees, the processing of them. And so be able to make that simple shift over to something that's going to be long lasting. I would like to see the long-term durability of it as well. I'm all for this. It would be neat to fast forward and get a, what's the 40-year cycle? What's the 100-year cycle? Just to know what the long-term durability is going to be, because otherwise, if it checks all those boxes, I mean, this really looks like a compelling product and so much better for the environment.
Yeah, and on the longevity front, they have been using this product for almost 40 years in Germany
Yep.
and throughout Europe, and those are good climates to look at because they're warm and moist. And if we're going to have issues with something at any point, by warm I mean relatively warm. Germany
Sure.
does not have many freezing days. It's like Seattle or Washington D.C. in climate zone 4. So yeah, I'm fascinated about that too. I was working on a project 3 years ago, a brand new addition to an existing house on North Winooski Avenue in Burlington, and that was a 2x6 stud wall filled with rock wool with 5.25 inches of Gutex on the outside. And one of the things I do like about the Gutex, and this product will have the same thing, is that they're keyed very much like flooring or anything like that. So they're not butt jointed, but on
Overlap.
two sides, but they have an actual key that gives you a really easy installation. And
Sure.
the hanging question is something that I think we should do some field testing on. I think we should get some 10-inch. We should build a like a 10 by 10 wall or an 8 by 10 wall, and we should put some on it, and we should see what happens. I know that JLC did a study. There was that exact question posed like in 2012, 2013, and we'll do some research and try to dig up that article where they were talking about we're hanging all this stuff off of these studs, and what happens if we put cementation board on it. It's an 8-inch screw that's 2 inches into the wood, and what's going on here. And oddly enough, that study found that much like the way bolts work, the squeezing increased the friction, and it wasn't really hanging on that particular thing. But I think we should definitely do our own field test, because first of all, I think field tests are cool as heck, and second of all, I'd like to see what the results would be. So
Sure.
challenge accepted. Let's wait until we can get our hands on some of this. We're talking a year before the rigid board, a year and a half before the rigid board is even available commercially. But I did hear names like Sticks and Stuff and Curtis Lumber and Rice Lumber. They're already in touch with these companies to make sure that we're going to be able to get a decent supply of this once it starts being available. So that's very exciting. So that's the show for today. Another great show. We are looking at a new segment for next week. We're looking at a 10-minute segment, looking at or maybe even longer, looking at building failures that we've seen in the field. Because that's really interesting. And I think we'll probably also take a look at some of your emails from the past and see if we can look at or walk through some of the solutions we've proposed, and maybe even share one of those instructional videos. So far, nobody calling in. It is a call-in show. Our number is 802-200-2550 between 7 and 8:30 on Tuesday evenings. Please feel free to call. If you're interested in getting in touch with us, you can also send us an email at housecallsvt@gmail.com, and we'll get on top of that and respond to you as soon as we are able. So until next week, this is Chris West and
Jim Bradley.
And we are
Have a great week.
We are House Calls Vermont, building science knowledge. Until next week, guys. Thank you very much.